Okay, so we are going to talk about series. So top of the next available page, title it series, and this is our definition. Some of the terms in a sequence, in other words, we're adding them up. We are adding them up. So we're going to do a little chart. On the top, we have a sequence. And on the bottom, we have the series. Not yet. We're going to fill in the series. I'm going to give you a second to fill that in, or just copy, and then we're going to fill them together. So I have 3 different sequences here. I have 3 different sequences. And I'm just waiting on the pencils to stop so I know we're ready. And forward. Okay, so a sequence is just a list of numbers. This sequence here is finite. I know it looks like finite because we say infinite, but it's pronounced finite, meaning it doesn't have the dot, dot, dot. It doesn't go on forever. So a sequence is a list of numbers. A series, we just add those numbers together. So 3 plus 3 is 6 plus 4 is 10. I almost wrote 6. But it's 10. So far, so good? Okay. The other 2 are infinite. They've got the dot, dot, dot. They go on forever. So my sum there would be 3 plus 6 plus 9 plus 12 plus dot, dot, dot. Right? We're not going to learn how to do that sum. Same here. 1/2 plus 1/4 plus 1/8 plus 1/16 plus dot, dot, dot. We're not going to learn how to do that sum. At some point, some teacher somewhere, if you continue in math, is going to teach you how to do those, but I'm not. Because we just don't have time. Now, I am going to show you some vocabulary. This vocabulary, these 2 words, you don't need to know. But I like to tell you them because I think they're kind of cool. This one, this sequence is divergent. This sequence is convergent. I want you to look at the numbers. I'm looking for the people at home. I just can't get out of that habit, I guess. I want you to look at the numbers and try and figure out what makes that first infinite sequence divergent and the second infinite sequence convergent. What do we think? What do you think, Caitlin? Yes, sort of. It does have something to do with that, but I could make a divergent one that has fractions. I could. This particular one isn't, but I think you're on the right track, Mary. So the divergent one is getting bigger, and the convergent one is getting smaller. That's a big part of it. But there's more than just getting smaller. It's more than just getting smaller. Look at the divergent one. It really is just that it's getting bigger and bigger. That really is it. The convergent one, however, you can have ones that get smaller and it not necessarily be convergent. So I want you to visualize, if you were to graph those, what kind of graph is that going to be? Linear, quadratic, exponential? What do we think? What do you think, Keith? The divergent would be linear. How about the convergent? Exponential. Growth or decay? Decay. So that one would be exponential. I know because I'm multiplying by a half each time. Exponential has an asymptote, right? So this would have an asymptote. That's what makes it convergent. It's going to converge to a value. It's going to get closer and closer to zero without ever actually getting there. So that's what makes it convergent. Again, divergent, convergent, you don't have to know those. All right, we are going to talk about partial sums. We are going to talk about partial sums. So what a partial sum is, another definition for us to write down, the sum of a specified number of terms. The sum of a specified number of terms. Okay, notation. S sub n. That's a capital S, big S. Stands for sum. Sub n. This means the sum of the first n terms. Sum of the first n terms.
Instead of like variables and it was numbers, what would like subs be? Because they're not exponential.
So a sub is not an operation, a sub is notation. S sub n, it's not telling me what to do with n. It's saying I want the sum of 10, the first 10. So it's a notation, not an operation. Does that make sense? It's a notation, not an operation. His question was, if you have the sub, what is that? What kind of function is that? And the answer is nothing. It's not a function at all. It is a notation. Okay, so let's do two quick examples. So we are going to find the indicated value. And in example 1, that value is S sub 4. Okay, so ready? S sub 4. It really is simple. I'm writing up the first 4 terms. So that's 20 plus 25 is 45 plus 4 is 49. Yes, it is a total coincidence that it ends up being the sum of the 5th term. Or it ends up being the 5th term. That's a coincidence. I'm not sure why it's happening. I'm going to play around with those numbers later to figure out why that's happening. Because I don't know. I don't know why it's ending up like that. But it's coincidental. It's not going to be that way. And you can tell that because the first 3 terms don't add up to the 4th term, right? Good? Okay. So example 2. Example 2. I don't know why I gave myself so much room. Go ahead and write it. What's my pattern here? What am I doing, Taylor? It's the squares. 1 squared, 2 squared, 3 squared, 4 squared. So my a sub n here would be n squared. So to find s of 7, s sub 7, which means the sum of the first 7 terms, I'm going to go 1 plus 4 plus 9 plus 16 plus 25, that's a sub 5, plus 36, that's a sub 6, plus 49, that's a sub 7. So that's the sum of my first 7 terms. And yes, I used a calculator to do that because I didn't want to make any addition mistakes. I could have done it in my head, I just didn't want to. Good? You ready for me to make it more difficult? So I'm going to show you some notation. And the notation at first looks like, what is going on there? But it actually simplifies things a lot, and it's a powerful tool that you're going to use as you're going into pre-calc and calculus. So we're going to use it in a very simple way. But then you're going to keep expanding on this notation. So I want to make sure we understand the notation. So summation notation, start by writing it. It's a way to represent a series, which series again means sum, using the Greek letter sigma. So let me show you how to write sigma. Across, diagonal, diagonal, across. That's how you write sigma. It's a Greek letter, capital S, sigma, get it? Summation. So again, to write sigma, you're going to go across, diagonal, diagonal, across. You'll see me do it super fast, and sometimes it looks kind of curvy, and that's fine. And we're going to start with this example here. So draw the example, leave space for all of the, sorry, I didn't need to go that far. Leave space for all the little bubbles. I'm going to fill in the bubbles to explain what everything is. My sizing is all off today. I'm going to let you copy it first. You see how that sigma has the extra little thingy right here and right here? When you type it, that's what's going to happen. But when you draw it, most people just do that. If you want to be real particular, you can draw the extra little pieces. That's just like using a different font. But when you type it using math type, that's what it's going to do. Okay, I'm going to explain everything. So when you see sigma, your brain should think summation. That's what the sigma notifies, is that we're doing summation. The 2n, that's your a sub n. That is your explicit formula for your series. I should have made my bubbles bigger. That's your a sub n. This n equals 1. That's where you're going to start. Now listen, we're going to start at 1 for everything that we're doing, because we're doing like a super quick, here's how you do sequences in series. We're spending a week on it. We really should spend 2 or 3 weeks on it if we wanted to get down to the nitty gritty. So we're always going to start with 1. But I could start at 5 if I wanted to. I could start at 23 if I wanted to. Okay? The top number is where you end. So it looks super complicated, but it's not. Here's what that means. This summation from 1 to 5 means do a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. That's what it means. And we are going to use our explicit formula to find those values. 2n. So for a sub 1, I take out the n and I plug in 1. Plus. For a sub 2, I take out the n and I plug in 2. Plus. For a sub 3, that's what I do. I take out the n and I plug in 3. And so on until I reach, whoops, crap, I was doing 2 times 5 in my head. And accidentally wrote it. So that's going to be, and yes, I'm going to use a calculator again. 2 plus 4 plus 6 plus 8 plus 10. I think I missed something. 2 plus 4 plus 6 plus 8 plus 10. Oh, 30. That's my answer. So it looks complicated, but it's a different way to ask you to do something quite simple. It's just asking you to add up things. That's what that sigma notation means. Wow, that was messy. Let's try that again. Sigma equals summation. So when you read this one, it means the summation from the first term to the fifth term of the sequence a sub n equals 2n. Let's do an example. We're just going to do one example. I keep looking for the people at home. Such a creature of habit. Are we good? Everybody's good? Having voice? Okay. Here is example 3. Go ahead and write it. So again, what this is asking me for is S sub 7. If I didn't start at 1, that wouldn't be true. I've got to start at 1 for that to be true. So it's asking me to add up from the first term to the 7th term. That's what it's asking me to do. And to get that, I plug in right there. That's my a sub n. That's my a sub n. So I'm going to plug in 1. Guys, listen, if you go ahead and put 0 there, that's perfectly fine. And then I'm going to plug in 2, which is just 1. And then I'm going to plug in 3. And then I'm going to plug in 4. And then I'm going to plug in 5. Then I'm going to plug in 6. And I'm going to squeeze in 7. So that's going to be 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is going to give me 10, 21. 21. It's just notation. The math here isn't hard. The notation can be a little confusing. Any questions on example 3? Okay, keep your notebooks out. Today's assignment, fortunately, is video notes. I know you can't get to it on Canvas, but you can get to it on YouTube. So go ahead and keep your notebook out, but go ahead and get logged into YouTube, and I am going to show you 3 things to search for. 3 things. There's 3 videos. There's 3 videos. So getting logged into YouTube. I almost did a math Excel. So I'm glad I didn't do that. Video number 1. I don't have it on here. You are going to search Gauss 1 to 100. Actually, let me see if I can get you it. This is what we want. This video right here. This video right here, this one in the middle. Add up every number 1 to 100 Gauss style. That's the one we want. That's the first video.
This is a check.
Open that one up.
And my grandson and granddad.
But don't start it yet.
Hello, YouTubers.
Don't start it yet. That's the first one we want to open. So again, add up every number 1 to 100 Gauss style. Open that one up, but don't start it yet. I'm going to give you all 3, and we're going to talk about all 3, and then you'll have the rest of the class to do it. Okay? All right. The next one is one I made. So let me pull that one up. This is the next one, arithmetic and geometric series formulas. So you probably want to search arithmetic and geometric series, and then look for the one by Heather Parker, because that's me. So that's the second video. Pull that one up, but don't start it yet. This was all nicely laid out for you in the assignment, by the way. It would be super simple if you could click on Canvas. So again, you're searching arithmetic and geometric series without the word formula. See the name of the, right here is the name of the thing. Choosing the one by Heather Parker. We're ready to search for the third video. And then still don't start it, because I've got some instructions to give you. The third video, we are going to search for, ready? This is going to seem strange. 1 plus 2 plus 3 plus 4 plus 5 plus dot, dot, dot equals -1 over 12. What? And add to that number file. That'll bring up the correct one, probably. This is the video right here, this one. So that's the third video.
Grammarly is your personal writing assistant for clear emails, confident messages, stronger essays.
Yes, I get 1. So 1 plus 0. I'm going to.
Okay, so let's chat about these 3. The first video, totally optional, but I highly suggest it because it gives you good context. I would watch this one at double speed. You do not need to take notes. Just watch. It's interesting. Okay? And it's only like 5 minutes long. So this one's optional. You don't need to take notes, but it gives you good context. If you don't watch it, the first example on my video is going to be confusing. Okay? The second video, my video, this is the required one. This is the one you are taking notes on. You are going to, when you can get into Canvas, take a picture of those notes and submit them. Now, assuming Canvas comes back on for us at some point today, that is due tomorrow, 7 a.m. On question 5, or on example 5, you need to have an attempt with work shown, and be turned in on time, assuming we can get it turned in on time in order for it to be full credit. So that 14-minute video is the required one. That's the one you're taking notes on. You're attempting the last example for full credit. Okay, good? And then the third video, again, totally optional, but it's going to show you that 1 plus 2 plus 3 plus 4 plus 5 plus ... is equal to -1/12. And if you think I'm kidding, I'm not. It really is. And that video shows it to you. Kevin's like, I don't believe you. I think you're lying to us, Mrs. Parker. I am not lying to you. Watch that video. Optional, you do not need to take notes. It's interesting. Plus, you get to hear the guy talk in a British accent, which is always fun. Okay? Does anybody need me to go over the 3 videos again? We're good? Okay. Go ahead and get those started then. So again, video 2 is the only required one. Don't tell me I wasn't recording that whole time. I was. Okay, good. Oh, hey guys. Y'all are there. Yay. Okay,